We use them every single day, often without even thinking about it. But what are rational numbers, really? Today, we're going to crack the code on this huge family of numbers, and you might be surprised by the one simple secret that holds them all together.
All right, let's kick things off with a bit of a puzzle. You've got a slice of pizza, a freezing cold temperature of -5 degrees, and the plain old number 7. What could they possibly have in common? Well, think of it like they're all part of a secret club of numbers, and today you're getting the password.
So what's the secret handshake? What's the password to get into this exclusive club? Well, it actually all boils down to one super simple but really powerful rule that defines every single rational number out there. And here it is. This is the big secret. A rational number is just any number that you can write as a fraction, p over q. That's the test. If you can express a number as one integer divided by another, you've found yourself a rational number. But, and this is a big but, there are two crucial conditions to this rule. First things first, both p on the top and q on the bottom have to be integers. And what are integers? They're just your regular whole numbers, 1, 2, 3, but also the negative ones like -1, -2, -3, and of course 0. They're the solid, whole steps on a number line. No funky decimals or fractions allowed for p and q themselves.
And now for the second condition, and this one is absolutely crucial. I kind of think of it as the golden rule of rational numbers. Q, that number on the bottom, can never, and I mean never, be 0. Why? Well, it's because in the world of math, you just can't divide by 0. It's like the one forbidden move. So any integer on top, any integer except 0 on the bottom, and bam, you're in the club.
Okay, so that's the theory, right? A bit abstract. Let's bring this back down to earth and back to our pizza slice to see how this rule actually works in the real world.
So let's look at these. Every single one fits our rule perfectly. 1/2? Yep. 1 and 2 are both integers. How about -3/5? Totally fine. -3 and 5 are both integers. 7 over 1? Check and check. And look at this last one. It trips people up sometimes. 0 over 3. Is it rational? You bet it is, because 0 is a perfectly good integer, and the bottom number, the important one, isn't 0.
And honestly, this is why the whole idea feels so natural. You don't even need to think about math rules. Just picture a pizza cut in two. You take one slice, that's 1/2. It's a perfect real-world picture. Rational numbers are really just about representing parts of a whole, an idea we've all understood since we were kids. All right, now for a little plot twist. It turns out some of the numbers you know best, well, they've been rational numbers this whole time. They're just in disguise, kind of like undercover agents, hiding right there in plain sight. But wait a second. What about a number like 7? Is that a rational number? I mean, you look at it, there's no fraction there. It's just 7. So how on earth could that fit our p over q rule? Well, the answer is actually so simple, it's brilliant. You can take literally any integer, like our friend the number 7, and just write it as a fraction by putting it over 1. The value doesn't change, right? 7 divided by 1 is still 7. But now, look at it. It's 7 over 1. It fits the p over q rule perfectly. And just like that, boom, its cover is blown. It's a rational number.
And sticking with that whole secret agent thing, just like an agent can have a bunch of different disguises, a rational number can be written in all sorts of ways. Look at this, 1/2, 2/4, 3/6. They look totally different on the page, but if you go back to that pizza, they all mean the exact same thing, don't they? You still get half the pizza. They're all what we call equivalent.
So we've got all these numbers, some in disguise, but they're all part of this one big family. The question is, where do they all live? Let's map them out. Let's find their homes on the number line and see how they all fit together. All right, let's start with a classic. 1/2. Where does it go? Right here, smack dab in the middle, exactly halfway between 0 and 1. A nice, clean, precise spot. Okay, but what about the negative ones? No problem at all. -3/5. Well, it finds its home over here on the left side of 0. It's a little bit more than halfway to -1.
And now for our undercover agent, the number 1. It's got its own special spot right here. And look at that, it's sitting right there, totally comfortable among all the other fractions. Because, as we've just figured out, it is one of them. It's just 1 over 1 in a very clever disguise.
Wow, okay. We've covered a surprising amount of ground here, right? We've gone from pizza slices to secret agent numbers. So let's just do a super quick recap of the main things you gotta remember.
So what's that secret code again? The one that gets you into the rational number club? Let's run through it. 1. It's got to be writable as a fraction, p over q. 2. Both p and q have to be integers. 3. The golden rule. The bottom number, q, can never be 0. And 4. The big aha moment, every integer is also a rational number. They're all in the family.
Okay, so we've got it down. If a number can be put into a nice, neat little fraction box, we call it rational. Simple enough. But this leads to one last really fascinating question. What about the other numbers? You know the ones I'm talking about? The wild ones, the decimals that just go on forever and ever with no pattern, no end in sight. What in the world do we call them? Well, that's where the number line starts to get really, really interesting. And that is a story for another time.